Waves. Some wave definitions. The period is the time for a single oscillation or complete cycle. It's measured in seconds. And the frequency is the number of oscillations that occur every second. Frequency is measured in hertz, Hz. For example, a pendulum swings back and forth 3 times in 1 second. The frequency is 3 hertz. 3 times in 1 second is 3 hertz. The period is 1/3 of a second, so it's only 1/3 of a second for each swing. Period and frequency, we use T, capital T for period, F for frequency. Here's a sample problem. A physics student watches 10 waves wash up on the shore in a minute, or 60 seconds. Determine the period in seconds. So if 10 waves occur in 60 seconds, the period is 60 seconds over 10 waves is 6 seconds per wave. That's the time for one wave. To get the frequency, we use T equals 1 over F. So 6 seconds equals 1 over F. F equals 0.17 hertz, or 0.17 cycles per second, 0.17 waves every second. Some more definitions. A pulse is a single vibratory disturbance. Amplitude is the height above equilibrium and directly relates to energy. Medium is the material that a pulsar wave travels through. The wavelength is the length of one complete wave. To get the speed of a wave, we use V equals F times lambda, where lambda is the Greek letter that we use for wavelength. With a transverse wave, the particles of the medium move perpendicular to the wave's direction of travel. Here you can see the wave is traveling to the right, but the particles are moving up and down. In a longitudinal wave, the particles of the medium move parallel to the wave's direction of travel. So here you can see that the waves are traveling to the right, but the individual particles are traveling left and right. Okay, they're moving parallel to the direction of the wave. Here's a longitudinal wave, velocities to the right, and you can see the vibrations are moving left and right. Nothing's moving up and down. Here's a transverse wave, the velocities to the right, the particles would be moving up and down. Crests are the peak of a wave, troughs are the bottoms. The wavelength is the length between 2 points on the wave that are the same, like 2 crests or 2 troughs. And the amplitude is the height of the wave from that midline. Alright, interference. When waves combine, they can add together or subtract depending on if they're going in the same direction or opposite direction. With constructive interference, they add together. You can see in this animation, one is +1, one is +0.5. When they combine in the center, I get a total of 1.5. There it goes. On the right-hand side, I have one that's +1 and one that's -1. When they combine, they cancel out, and I get them to flatten in the center. Notice that after they combine, they just keep traveling as if they hadn't interacted at all. Alright, constructive is when they add together, destructive is when they cancel out. Sound is a type of wave. It's transmitted as a longitudinal wave, meaning it's parallel to the direction of motion. It's a mechanical wave, so it requires a medium to be transmitted, like the air. The speed of sound in air is 331 meters per second. There's a speed in water and steel. And the amplitude of a sound wave is synonymous with volume, or loudness, or intensity. The Doppler effect. A source sends out waves in all directions with the same frequency and wavelength. How the wave is perceived depends on the motion of the source and the observer, though. So, in an example, if you have a fire truck that's stationary, that's not moving, then an observer at point A and B will hear the same frequency. Alright? But if the fire truck is moving towards point A, the waves are getting closer together at point A. So when you're at point A, the frequency is going to be higher, the wavelength is going to be shorter, and it's going to be observed in a higher pitch, higher frequency. At point B, the waves are more spread out because the fire truck's moving away. So this is going to be a lower frequency, a higher wavelength, and a lower pitch. Alright, so this you might notice is anytime you hear a car drive by you. Alright, when it's coming towards you, it's a higher frequency, higher pitch. And then after it drives away from you, it comes a lower pitch.